So here are some notes on pure substances versus mixtures if you wanted to go along with me as I walked you through these notes. So the first thing that you'll notice is um, I've embedded the Chem Catalyst questions here. And the reason I've embedded these is because sometimes these questions show up as test or quiz questions. So I could ask you a question like, what is matter, or what's an intensive property? What is a pure substance? Our big focus here is going to be what is a pure substance and how can you describe mixtures? Then we're going to look at, in our next class, how would you separate different mixtures? So as you notice, this is the slide that covers the material that was in the very first video that you watched for this unit. When we looked at the properties of water versus ethanol, we looked at the fact that water is colorless, ethanol is also colorless. Water doesn't have an odor. Ethanol has a very clear odor. If I were to have lit the two on fire, water would not be flammable, but ethanol is. Water and ethanol have different densities. So ethanol would technically float in water. Now, different properties cause water and ethanol to be able to mix a little bit better. They have different melting points, boiling points, and different things will dissolve in them. So that was something that we looked at in that very first video. But both of these are pure substances. So what makes them pure substances? A pure substance is going to be uniform and definite in composition. So for example, if you picked up a cup of water, everything within that cup of water, if you have purified water, is just water. It's just H2O. H2O is a pure substance. You go to your cabinet and you grab pure salt. Pure salt is, table salt is NaCl. Okay, that is a pure substance. That container only has one type of compound in it or one type of substance in it, and that one substance is NaCl. Each sample has the same properties. So this kind of goes back to when we were looking at gold with density. If I took a chunk of gold from one place and a chunk of gold from the other place, both are pure substances of gold. If they are pure substances, every single piece of that gold is going to have the same properties. So for example, water is going to boil at a certain point when it is just water, when it is a pure substance. But when water is turned into a mixture, meaning I've dissolved something in water, water is actually going to increase in its boiling point. Now, I'm not going to test you on that, but it is kind of interesting. So you'll hear some people say if you add salt to water, it's going to increase the boiling point, which basically is going to say that things will cook faster. You would have to add a whole lot of salt for that to happen. Really, we just add salt to a boiling pot of water for flavoring to our pasta, but that is what will happen eventually if you add enough salt, is that the boiling point will be increased. Now, pure substances cannot be separated by physical means, meaning I can't separate them by magnetism. I can't separate a pure substance through boiling. A pure substance can only be broken up through a chemical reaction. And a pure substance can be either elements or pure compounds. So right here, it says, what do you think a model of these would look like? You can go ahead and hold off for a second and draw what you think, and then check them on this next slide. So this is what pure substances would look like, or mixtures. So I have this right here. Our element is a pure substance. Our compound is a pure substance. Our element here is a pure substance. But here I have a mixture of elements and compounds. Here I have a mixture of elements. And here I have a mixture of compounds. Okay, so that's how you would draw a visual representation of what do the particles look like. So if I ask you for a zoom in model, I'm looking for something like this. These visuals will show up on an assessment. I would like for you to be able to identify what is an element, what is a mixture, what is a compound by these visuals. Now, a mixture can be separated by physical means. A mixture is composed of two or more pure substances. So I've mixed it, and I have two different types of mixtures. I have a heterogeneous mixture and a homogeneous mixture. Heterogeneous mixture is different throughout. So if I'm going to chop up like a really nice garden salad, I'm going to put some tomatoes, some bell peppers, cucumbers. When I take a scoop of that salad, I'm going to get different salad in each bowl if I'm going to put that in a bowl. And so, an example that I use often with this is like when you go to Olive Garden. When you go to Olive Garden, you go in and you take a big scoop. Now, some people get olives in their salad, but other people don't get olives in their salad because of the number of olives that are given out. That is an example of a heterogeneous mixture. It is different throughout. It's not all consistent and the same. So, like a scoop of sandy water, that would be a heterogeneous mixture. You can see differences there. A homogeneous mixture is also known as a true homogeneous mixture is known as a solution. A homogeneous mixture is the same throughout. So if I have salt water, if you're going to like play a prank on someone, you're like, oh, here's some water, and you put salt in it and it's all dissolved, that's going to be a homogeneous mixture. Someone's not usually going to be able to tell that it's a mixture of salt and water unless they've tasted it. I would say something like Kool-Aid would also be a good homogeneous mixture if it's mixed very well. Now, in a homogeneous mixture, substances are going to retain their properties in all mixtures. Okay. So once I separate out those substances, those pure substances, now they're going to have that one pure substance is going to have its specific property. So you can separate mixtures based on these properties. Here's an example of we have a pure substance that's an element, another pure substance that's sulfur. Now, if I make a mixture of the two, this is going to just be a mixture of iron and sulfur. I can separate iron and sulfur from each other, and I can do that with a magnet because iron is magnetic. Whereas if I melt that and burn it, if I get enough energy in there, the iron and sulfur are going to react with each other and they're going to produce a compound, which is another pure substance, but a new pure substance of iron sulfide. Okay, so we have a pure substance mixture, but then after a chemical reaction, a pure substance. So this is just kind of a diagram that splits matter. So matter can be split into two properties, a pure substance or a mixture. A pure substance can either be a singular element, and that's going to have one element, one type of element there, or a compound that has more than one element. So you see, I have a C and an H. If I have capital letters, each capital letter represents a new element. In the mixtures, I have a homogeneous mixture where everything looks the same throughout, whereas here I have a heterogeneous mixture where it's not uniform and things look different. So an element is going to be a substance that cannot be decomposed by chemical reaction. So it's going to be the most simple, basic form of matter, but I cannot break that down through a chemical reaction. And we're going to go into that more in our next unit. But the building block of matter is an element, and the smallest unit of that element is called an atom. A compound is going to be when two different elements are chemically combined. We've chemically combined them, and so there is some kind of bond between them. So, for example, H2O is a compound. NaCl is a compound. Na is sodium, Cl is chlorine or chloride. Now, our symbols. This is very important so you can tell when you're doing your lab which one is a pure substance of an element and which one is a pure substance of a compound. So if you have more than one capital letter, it's a compound. If you have only a capital letter and lowercase or just capital letters, then that's just that's an element symbol. So chemical symbols represent elements, but chemical formulas represent compounds. So this right here is carbon monoxide, and that is a compound because you have two uppercase letters. And then this is just another diagram to help you, again, see the difference between a mixture and a pure substance, a heterogeneous mixture, homogeneous mixture, compound, and element. I'm really trying to give you guys as much information as you can use to help you with this lab that you're about ready to start. I hope that this is helpful. If you need any help, please go ahead and reach out to me via email.